This is a Math 2 lesson summary video for the lesson entitled Seasonal Systems. In Unit 6, Lesson 8, Seasonal Systems, the purpose of this lesson is to continue writing equations from a context, or given within a word problem. We will continue to develop methods for solving systems of equations and inequalities where one equation is linear and the other is either an inverse variation function or a square root function. In Lesson 8, Seasonal Systems, we are told that Family Kingdom Amusement Park is planning to hire more support staff to work during the summer months, and they have budgeted $12,000 per week to go for the pay of these seasonal workers. We are asked in number 1, if Family Kingdom Amusement Park hired 60 people, we are asked how much would each person make per week. So let's define a variable first. Let's let x equal the weekly salary per person or the pay per week per person. So if they have budgeted $12,000 and they hire 60 people, we know we can divide $12,000 by 60 to figure out how much money per week we could pay each employee, and that would be $200 per week. If we're looking for an equation, we could write that 12,000 should be equal to 60x, and divide both sides of that equation by 60, and we'll get x equals 12,000 divided by 60. So the amusement park would be able to pay $200 per week per person. In number 2, we are asked to create an equation, a table, and a graph that models the relationship between the number of people that the family amusement park can hire and the weekly pay per person. Recall that we've already written an equation in the form 12,000 equals 60x, and we've solved that for x. And we've got x to be 200. When we used Desmos in class, or our graphing calculator, we did type in. So let's talk about the relationship between the number of people the park can hire and the weekly pay per person. Keep in mind that as the number of people the park hires goes up, what's going to happen to their pay per week? Well, the more people the park hires, the pay per person is going to go down. Recall that when one variable is increasing and the other one is decreasing, this is an inverse variation function. Therefore, our equation that we're going to type in our graphing calculator or Desmos is y equals 12,000 divided by x, where 12,000 is our constant of variation in the equation. So what we did was we typed this equation into our y equals, and we looked first at our graph, or our table. Here we have our table of our x values plugged in and our y values. So what we did was we took each of these coordinate points and we can graph them on a coordinate grid. We can also hit second graph and see that the graph of this inverse function looks just like so. And we can check the points 50, 240, 100, 120, so on and so forth, and notice that these keep going in both directions. Moving on to number 3, we are told that previous years the owners of Family Kingdom Amusement Park have realized that the more money they advertise for pay per week, the more applicants they receive, which makes sense. The more money you're going to get paid, the more job applicants you're going to see. 2 years ago, the owners advertised the seasonal part-time work as having a weekly salary of $205, and they received 40 job applications. Last year, they advertised a weekly salary of $220 and they received 50 applications. So we see an association between the $205 and the 40 applicants and the $220 per week and the 50 applicants. We are asked to create an equation, table, or graph to model the relationship between the weekly salary advertised and the number of job applicants. Well, since we know two variables, we have an input and we have an output, we can actually figure out what the rate of change is, or the slope, given these 2 points. So this will be my x and my y values. Recall slope formula, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1 from Math 1. So let's plug in our values. 50 minus 40 divided by 220 minus 205. Therefore, our slope, or our rate of change, would be 10/15. We do know that this is a linear function, so it will be in the form mx plus b. Now recall from Math 1, in order to get the b value, you would have to plug in 1 point in for x and y. So let's plug in the 205, 40 in for x and y to get our y-intercept. So 50 equals 10/15 times 220 plus b. You can do that math, but when I solved that for b, I did get that my y-intercept was approximately negative 96.6 repeating, or as a fraction, negative 290 divided by 3. So my equation here is the equation y equals 10/15x minus 290 divided by 3. Just to save some room, I'm just going to erase this piece here. Okay, so then we were asked to display a table and graph. We typed this in our y equals, and we got the table as such on the right. Then we hit graph, and we were given this linear function. So we have provided an equation, a table, and a graph to model the relationship between the weekly salary advertised and the number of job applicants the owner will receive. So let's now look together at number 4. In 4, we're asked how much should the owners at Family Kingdom Amusement Park advertise as the weekly pay if they want for the number of job applicants to be the same as the number of people they can hire. Okay, so let's keep in mind that we're sticking with X being the weekly salary. So we need to figure out how we can compare those two values. We want it to be the same, which means that we want our two functions to be equal to each other. So what we're going to need to do in this case is we're going to need to take the equation that we developed for the weekly pay per job applicants and the number of people that they can hire. So we had two equations. We had an equation y equals 10/15x minus 290 divided by 3. And we want to see where that equation, I'm going to set it equal to the other one because they're both equal to y, is equal to our inverse function. So we have a linear function set equal to an inverse function. So what we did in this case is we looked at a table. We typed the line in y1 in our calculator and the inverse function in y2. And what exactly are we looking for? We're looking for where the values will be exactly the same. So I do notice in my table that when x is 225, we have 53.3 repeating for y1 and y2. That means that x equals 225 will be a solution. Now, we also notice in our table, as well as our graph, that there was not only one intersection point, not just at 225, but there's another intersection point here. Recall, though, that we can't have a negative amount of salary, so our x value cannot be negative. Therefore, this value over here will not make sense, and our only solution would be $225 per week. This also means, to answer the second question, how many applicants will they receive? They will receive approximately 53 applicants. So the weekly salary would be $225 for approximately 53 applicants. So on 5 and 6, we did talk in class about how those are inequalities, but we are going to move to number 7 to see how we can solve a function where we're given a square root and a line in a linear function. So we are asked to solve this system by graphing and using a table. So what we've done here is we typed this y equals the square root of x in our y1. Recall to use your graphing calculator, you do need to get the y by itself. So we subtracted x, and we divided by -1, and we got y to be equal to x minus 6. And we typed x minus 6 in y2. What we're looking for here is we're looking where the solution is. Recall that the solution between a line and a square root function should be where they intersect. So if I look here on my graph, I'm looking to see where the two intersect. And I see that n x is 9, my y values are the same, which means that x equals 9 should be a solution. Once you find 9, we know that 9, 3, or the point 9, 3 should be a solution. And when we graphed it, we indeed did see that 9, 3 was our point of intersection. So now let's work through the algebra. And number 7's equations are the exact same as 8a. So let's try and solve with the math. We already know that x minus 6 or x minus y equals 6 is equivalent to x minus 6 when I get y by itself. We can set those two equal to each other and square both sides of the equation. We are going to get the quantities x minus 6 times x minus 6 multiplied together. We can distribute the binomials. We'll get x equals x squared minus 12x plus 36. Subtract x, and we will get 0 equals x squared minus 13x plus 36. Recall that this is a quadratic function from Unit 4 and 5, and we can factor it. When we factor this, we will get x minus 9 and x minus 4. So our solutions will be 9 and 4. But if we go back up here, we did not have an intersection when x is 4. Therefore, I already know that this answer is going to be extraneous. But let's check it just to be sure. The square root of 4 is 2. That checks. And I'll do the x minus 6. So 4 minus 6 equals -2. So that does not work. So you notice in my check that the only solution is 9. And when we plug 9 back in, the square root of 9 is 3. So my solution is 9, 3. And that would be the full algebra to solve 8a. Let's now take a look at f. In order to solve two square root functions, we can set them equal to each other because they're both equal to y, and we can use substitution. To get rid of our square root, we'll square both sides, which gets rid of your square root. We're left with a nice algebraic equation, x plus 1 equals -x plus 7. When we combine like terms, we get 1 equals -2x plus 7 minus 7, -6 equals -2x, and divide by -2. Therefore, x is 3. Once you get x, you do need to plug it in order to get y and see where the two intersect. So 3 plus 1 is 4 is 2. Therefore, my solution here would be 3, 2. Let's do one more. Let's do an inverse function on e along with a line. So again, we'll do the same thing. And we will set them equal to each other. -3x plus 1. Recall from the previous lesson that we can multiply both sides by x. That will cancel. We're left with 5 equals -3x squared plus x. If we subtract 5 on both sides, we get 0 equals -3x squared plus x minus 5. So we know -3x squared plus x minus 5 cannot be factored. We can use quadratic formula, but what we will notice when we use quadratic formula is that we will get imaginary solutions. So let's take a look visually at what's happening here. When we plug in our quadratic function into our calculator, notice that this parabola does not touch the x-axis. Therefore, we would say in this case that there are no solutions for E. If you need more help on solving linear and inverse, as well as linear and radical functions, please check the Canvas Student Support site.